was.
At the time.
Yes, and then I was like, okay, so you want to meet up now? And then he gave me an answer, and you didn't give me an answer. I just waited, and I stared at the picture, the crude picture that I realized won't work because it gives us 2 collisions. Because it sucks.
Oh shoot, dog.
I don't know anymore. What are any of us talking about? What's the point in anything? Why does
It's okay, we'll figure it out.
Where's my pencil? I have my pencil. Okay, so this doesn't work because that gives us 2 collisions. So it needs to be like this, where they don't actually meet until they're inside the box.
I didn't think were they supposed to actually intersect and become one too?
What? The way that we drew it, they would intersect here, but that's not gonna work. They have to be like 2 separate things. Otherwise, it gives us 2 separate collisions, which and Micah abandoned us.
Is this one collision of between like 4?
Yeah.
Is that what that is? Okay. So we're gonna have to have a series of smaller ones going into each. But that makes sense. Okay.
Yeah. Just the whole.
Oh, I didn't see those. I'm dumb. Okay.
Where else? No. He's all the way over there. Why? I want to die.
Because I think we're not actually working on this in class today.
Shut my face.
Well, I'm busy from 4:30 to 6:30, so.
No. What?
This evening.
What?
Busy from 4:30 to 6:30.
My life is wrecked.
I have nothing going on for the entire evening, so I can just work on this the whole time.
What did we assign parts again? I know I'm drawing it or something.
On cost. We're supposed to cost.
What's Nolan doing?
I don't know.
What's he
I
doing?
think Nolan was supposed to do the word description. Which will leave you with the energy calculations. Which are both the easiest.
So, just a few quick words. I've answered a bunch of emails this week. Happy to answer more tonight, but there's a limit to how late I'm going to stay up. So, keep that in mind. If you send it at a reasonable hour, I'll get you a response. So a few things to know. First of all, if you have stable particles, electrons, positrons, protons, antiprotons, primarily, or anyone else you can think of, if you have stable particles, you can keep them in the ring. So, for example, what Fermilab did for the Tevatron was it takes a while to build up the antiprotons, but once you inject them into the ring, they basically will stay there for like a day. They last around a day. So you actually don't have to continually produce antiprotons and similar particles. Well, then the antiprotons and positrons. You don't have to continually produce them. They'll stay in the ring because you get what 10 trillion protons in the collider or something. At Tevatron energies, you're going to be much higher, of course. So at Tevatron energy luminosity, you get 10 trillion protons going one way, 1 trillion antiprotons going the other way, and they collide. Every time they cross, they get 1 collision on average, right? So you don't run out. Right? They eventually get lost just because you can't keep them. You don't perfect beam optics. You can't keep them in. They just get lost over time. So stable particles can stay in the storage ring. Unstable particles, of course, have to be continually produced because they disintegrate very rapidly. So that's just something to note. Make sure, like I mentioned, you should account for the tunnels connecting your accelerators, right? That there should be some extra distance there. It's not very expensive compared to most of it, but you should just make sure you have that in there. Make sure you have RF in all your circular accelerators. It has to be in there somewhere, right? Otherwise it won't accelerate. So make sure you have RF cavities in there somewhere. And if you are doing unstable particles, based on some emails I got, and a few people doing unstable particles. If you're doing unstable particles, when you calculate the time based on the distance, you have to calculate how many turns around the accelerator they'll need, right? So you have an RF cap. Let's imagine you put 1 RF cavity in your circular accelerator, right? For protons, that's fine. It might take 10 minutes to accelerate, and that's no big deal. Once they're accelerated, you can leave them in there. But if you're doing with something unstable, right, a muon or something, then it goes around. It'll get. What does it do? 1 MeV, let's mention just 1 MeV. You'll get only 1 MeV every time around. right? So accelerating will take, accelerating it by 1 GeV will be 1,000 turns around this thing, right? Which will give you, which increases the time which you have to factor into your the decay of your particles. So that factor is an important one. So if you're accelerating something unstable, you probably want a boatload of RF in it because you need to accelerate it fast. And you don't have time to wait going around. Now, if you're selling something stable, then no problem. Put in a small amount of RF and you'll be fine. Okay, does that make sense? We all remember what RF is, right? RF is the acceleration, the things that actually accelerate. And they do it, each thing works. So if you're doing things, then that's when it's linear accelerators and things with unstable particles that will tend to want to use the superconducting RF or similar technologies that give you a lot of boost for a small amount. If you're dealing with protons, it's a waste of your time, right? But if you're dealing with unstable particles or with a linear accelerator, then you can save on using more powerful RF. So that's that. Okay, logistics. You need to. I would like this submitted on Moodle. I'm just about to open up a spot on Moodle. So I'd like to submit it on Moodle, and I would really like it in a single document. It is much easier for me to keep track of. I want it all electronically. If you are doing a scale drawing and drawing it, that's cool. Take a nice photo or scan it. When I say a nice photo, I mean at least just make sure it's readable, there's no glare on it, and stuff like that. Or scan it or whatever, right? That's plenty of facilities for that now. They even have nice phone apps that do a decent scan of it yourself, that you can do with a smartphone. Anyway, go ahead and please put it all into one document, Word document probably, or PDF if you prefer, and put it all in one document, please. If you have an Excel spreadsheet, for the people doing like cost analysis or something, if you have it on an Excel spreadsheet, that's fine, but you can make do a screenshot and import or something so that it's all in this document so I can see everything. Does that make sense? Obviously, be careful if you're going to try a screenshot of an Excel spreadsheet. It might, you have to make sure the zoom is high enough and like that. But I think you should be able to copy and paste between them, right? You should be able to copy and paste from Excel to Word. So if you're having any trouble, your Word, it might not come up. Also attach the Excel spreadsheet separately, just in case if you have any concerns about that. Okay, so you should have that. In there as well. For the main description, expect description, make sure give me reasons and also give me energies, especially energies, right? Like I want to know the energies of each of your accelerators. Please make sure that's in there because that's the one that's not obvious from everything else. Okay, so I really want to know max energies, magnet strength, stuff like that, stuff that isn't listed other places, or even stuff that is, right? You know how I gave you the size for the little homework assignment? I gave you the size, the radius, and the maximum magnet strength, and you calculated the maximum energy. Like I would like that in your summary. So first doing summary, please give me that from each of your accelerators in the accelerator chain. Remember that there has to be a chain, right? Okay, or almost has to be. You can come up with something clever, maybe you can work your way around it. I don't know. Next. Yes, okay, first doing the cost analysis. You can do it, there are two approaches you can do. One is a nicely laid out Excel spreadsheet that makes things clear, that labels everything clearly and makes it obvious what everything is, in which case I recommend you use colors and boxes and things like that to make it obvious what I should be looking at, okay? Or you do a short, or you have that spreadsheet and then you do a short write-up that summarizes what happens, and that also is fine, right? I just want it to be clear. I'm not going to be poking around through a bunch of unlabeled Excel cells, okay? So it has to be a report, not just an Excel spreadsheet. Does that make sense? Okay. For the luminosity person, I would like your calculations written out clearly. You can do it on paper, you can do it on computer as you prefer, and I don't need to, you don't need to tell me how you multiply the 18 times 3. But you can tell me I use this equation, I substituted in these for the variables, because you can screw that up, so I want to see if you screwed it up, right? And then I'm going to assume you knew how to use a calculator, but I want to see the equations you use, how you derive. Some of those variables are easy to derive, some of them are a little more complicated. I want to see how you got all that, so that I can determine if you calculate the luminosity correctly. The standard units of luminosity are 1 over square centimeters and 1 over square centimeter second. So usually written like this. Those standard
Square
units would be
centimeter
not.
seconds.
Yeah, I know, right? Yes.
How do you find the collision?
What's that in G?
Collision frequency you should be able to get because I told you how closely the bunches have to be spaced. Remember, the maximum is 20 centimeter bunches separated by 20 centimeters. That's the minimum spacing you can get. If you're at the minimum spacing, then you can use the fact that they're going at the speed of light to figure out the collision frequency. Do you remember that they do have to fit around the circle? So there has to be obviously an integer number of them around the circle, although your circles are probably so big that that is going to be lost in the round off. So yeah, so that would be, that's going to be your maximum frequency, so you can use that. Yeah?
I guess based on or based on the numbers you gave us, should this frequency
I would like it to be, everyone would like it to be there. I don't know LHC numbers as well. The Tevatron collided at a frequency of 5.7 megahertz. So 5.7 million was their frequency. The LHC's is higher. I think it's like 12 million, like that, 30 million, something like that. Anyway, LHC is very high frequency. So yeah, high frequency is good. That raises your luminosity. Is everyone's frequency going to be the same? Not necessarily. But there might be some similarities, yeah. Depends on the thing. But if you're producing, especially unstable particles or even stable particles, it may affect your frequency just because of how much you can produce at a time, right? You might try and pile up a little bit in the storage ring, for example, first, and that would lower your frequency, but increase your other beam parameters. So there are differences that you can make. But I mean, if everyone were doing a proton collider, which would be boring, then yeah, everyone would probably have the same frequency. You don't go stat as much as you could, right? Okay, and if you're doing the scale drawing, again, by paper is fine, by computer is fine. The top view should be superimposed on a Google map, right, and drawn to scale. You may discover that the scale is ridiculous. That's to say, some of the early accelerators will not even be visible on the scale of the largest accelerator, because this accelerator should be pretty darn big. You have kind of a choice of orientation of it. Remember, the collision points is definite IMSA, but you have a choice of where you can orient anything, and I recommend you choose something that's just kind of interesting. Just, you know, whatever you're building underground anyway, right? Wow, totally lost it. However, because of that, you may end up needing to make two. One zoomed out that has basically just the giant one. The last accelerator is going to be huge. And you might not be able to see anything else on that picture, so I might need another one that's zoomed in and shows me just the smaller chain. Okay? And that would be the preferred way to do that. Then for the side view that does the elevation, that was probably really simple. Okay? It's mainly to show, can you consider the different depths that you're digging at, because you can't have two accelerators on top of each other at the same depth. Okay? They should be, I said, 10 meters apart, because otherwise the radiation from one will interfere with the other. Ooh. So you have to stack them up. If you're going to stack them, they have to be 10 meters apart. You know, there's a variety of ways around it. One is don't stack them. Right? One is when you stack them, you stack them in a way that'll be most cost efficient. Right? I'll let you decide that, because the deeper you dig, the deeper you dig, the more it costs. Right? Okay. So those four things. That's basically what I'm expecting. I'm saying more in words than I did on the paper. So hope they're listening. Okay.
Why does it have to be below ground?
It does not have to be below ground. If you choose to build above ground, however, you cannot go through any populated area because there's already houses in them. So you can't just build, you know, and then demand's not making that far. Well, okay, I guess if you want to factor in the domain cost, that's going to be very, very pricey. That's going to add your per meter, how many meters wide is the house? 10 meters? That's going to cost $1 million basically. So then if you build above ground, you can't go through any currently occupied area. And you have to buy the farmland if you're going through farmland. I mean, virtually every bit of land is owned in Illinois, right? So you that. Plus, you need to build substantial shielding, which if you ask, I'll give you a price on. But anything above ground needs to be shielded. If you build underground, you use the ground as the shielding. If you build above ground, you need to build your own shielding. It doesn't have to be 10 meters thick, because that's just earth, but probably a few meters of concrete still, I think. So that's the disadvantages of building. The expense of buying the land is the main thing. that limits stability. But if you come up with something, by all means, let me know, and I will tell you, and I will give you a price on it.
So you want to
The other, so again, one document. So please leave a little bit of time to assemble that document. I am not giving any class time for it. Right? We come in tomorrow. We'll go over the quiz. We'll talk about core relativity. We'll go back to relativity. Okay. If you have not settled on pretty much the final design, do it. Like, just pick something like that. But I don't really like that. Oh, that's not really original. You got to get going, right? You got to find your accelerator chain, right? You got to figure out how many accelerators you need to get to the big one, and that takes a little bit of time to work out. So if you have not settled on the final design, just do it. Just pick something and go. Okay. If you're like, it's not very original. Okay, it's not very original. It's all right. You'll still do okay. You know. Yeah.
Wait, you're saying accelerators? Like
Yes, you need an accelerator chain if you're doing circular accelerators. If you're doing linear, you get away with this one. Yeah. No. A chain of accelerators. Circular. If you're doing circular accelerators, right? We talked about this. You typically start with linear accelerator because the early stages have to be linear. The circles don't work well with slow particles. You need just a little bit to go, and then you need circular accelerators that ramp up in energy. And that's because each accelerator has a minimum, any circular accelerator has a minimum energy it can take, as well as a maximum energy. So you have to be able to get, so you cannot, if you just try to shoot from a linear accelerator into the LHC, for example, then you would either need a very long linear accelerator, or if you try to shoot it in too low an energy, it won't stay in the beam pipe, and that's very strong, and they can't get that weak. Okay? So because of that, you have to make sure that the maximum energy of this accelerator is greater than the minimum energy of this one. And the maximum energy of this one has to be greater than the minimum of this one. Right? And that allows you to step up the acceleration. There's actually several other advantages that come out of that, but those don't affect you. Yeah.
How do you calculate the minimum?
Minimum energy is 5% of the maximum energy. And it scales linearly with the magnetic field. So whatever your maximum magnetic field is, 5% of that is your minimum. And so that because of that, you're kind of stepping by orders of magnitude, right? And so if you're aiming for an energy of 100 TeV or something, then you're going to need quite a few accelerators to reach that. I gave you a starting acceleration from the pre-accelerator.
Or else I can't do
what did I say, 100?
Same here.
No, what was it?
I can't do my job.
Somewhere in there it tells you what you get from your proton source, like the energy that come up. What is it? 3 MeV? Okay. So 3 MeV is pretty slow. We usually work on TeV, right? MeV is a thousandth of a TeV. And so, but the good news is you'll accelerate through that pretty fast, right? But you still will need to do a little bit of work. So typically start with a linear accelerator first just to get it up to a decent speed, and then start building circular ones. And you'll need a chain of them. And for the amount of money you have, you'll probably need 5, 6, 7, I'm not sure, to get up to the big one. Yeah. It's up to you because it's just a question of when you want to switch from linear to circular, and so you have to make that decision. If you start circular too soon, you'll just need a whole bunch of tiny circles, which is kind of not really very efficient use of your time, right? But of course, you want to switch to circulars when it becomes more efficient. Otherwise, you need a really long linear accelerator, and that's not necessarily helpful either. So it's a matter of balancing things. You know, honestly, this is not that much of your money, so if you get it slightly off, no big deal, honestly. Okay. Considering how much money you're spending on the giant build, right? So, you know,
Let me get cost 4 times.
you're not worrying that much about it, but you do have to make sure the physics works. So the maximum
but
energy
it was
of
4
one
times the
is
energy
greater
is the
than
idea.
minimum energy of the next one. Now, I recommend leaving a little bit of headway, don't make it exactly equal because that's not really going to work, you know? Yeah. Yeah, sorry, I didn't draw that. There should be a one. Well, in this particular case,
He was suggesting just doing 2, but having an
process,
input
now you have to
in
build a
each.
different
By the way, isn't the idea that there's an input in each of these?
Yeah.
Then this,
See,
they have their own
the thing is, I don't
built
know
in,
if we even have enough
right?
money for that.
If you have them overlapping, they'll have to be different depths. Otherwise, they
Give me some numbers to work with.
this is therefore the most common way of connecting accelerators together is just to have them touch at one point. That's the easiest way to do it because then you don't need a tunnel. But sometimes if you have a bunch of these, it gets harder to figure out how to do it. Tunnels are relatively cheap, can be built fairly easily. Don't need any magnets, so basically straight shots, so you don't need to put any magnets in them. If you want, you can put RF in them, but you probably don't need to bother with it. You got your circular accelerators for that. Yeah.
So with like the unstable particles and luminosity analysis,
Yeah.
so you need to first calculate the amount of particles that like remain after the time and then use that number of particles and particles for launch state?
Yes. Yes. Okay. All right. So I give you the rest of this time to work. Like I said, if you haven't yet, finalize your basic plan quickly so that you can get going on figuring out the accelerator chain and ask me questions. That's fine.
We enrolled in MPhys in 2016,
The
right?
actual thing.
Yeah, you guys were. All right, so here's what I'm thinking.
What class of 2019?
So the idea is that we have 4 different sources, 4 different big ones that connect in one big thing. I feel like once we get above 2, the benefit of having more would be outweighed by
cost.
yeah.
Besides, only having 2, putting sources in bulk, and making double beam pipe would cost less.
So we're doing.
Oh, we could just do a double beam pipe.
This is gonna happen.
A what?
If we only made it 2 and used a double beam pipe and put sources in each, it would be equivalent energy-wise and cost-wise.
Comes in.
So like,
This one could be proton.
wait,
Proton would be one.
okay, so I'm gonna erase 2 of these.
Okay.
Wait, I'm gonna erase one of my copy. I don't need that copy.
Yeah, we know.
P. What this is going to do.
If you make it large enough, I'm not sure it'll be
here.
cost efficient.
You're going to get a
but
lot more.
you can try it. Yeah.
So where are you saying we should put it?
Well,
What am I saying? We should put what? Because I'm saying this whole thing can now be a double pipe. We should have a source here.
Yeah.
What? Oh, because we need 2 sources if it's a double pipe. So 2 sources, 2 sources, right? And this is a double pipe. And so we'll have linear accelerator, as many loops as we need, big one, and then the actual collision will happen here. And it'll still be like 4 hitting, but it'll actually cost less because we don't need to build 2 more accelerators.
So, like,
so yeah.
Does that make sense?
So we're sending 2 out at the same time on the same path?
Yes.
How do we make sure they don't like...
They have 2, there's 2 beam pipes.
Oh,
That's
okay.
double beam pipe, yeah. There's 2 beam pipes.
I think that's how it works.
Yeah, that's how.
I think if it's called double beam pipe, I sincerely hope it's
There's 2 beam pipes. Yeah. All right, so we need
How many
to.
loops do we need?
We need to first. We need to decide on some numbers. We need to decide on what we want the maximum energy of each big one to be.
And the minimum.
Yeah, well, minimum energy comes from maximum. So basically, we just need to say,
What is average energy?
give me a number between 1 and 10 Tesla.
7
7?
and a half.
It's easier if it's an integer. 9, you want to do 9? Alright, each of these can be a 9 Tesla collider.
You know
I
it's
might-
9 to 13, right?
I might be able to do it
Is it really? Is it 9 to 13?
I might be able to make a
they're going to have to.
A
3D model.
That's awesome. Alright, so do you guys want to make it 9 or 10 or what?
9, 10, 11, 12.
Let's make it 10 to make our numbers easier.
Thank you.
You're welcome.
I forgot about that. I forgot I have to do the math anyway.
I have to do math too, so let's make it a nice number. So 10 Tesla. You know what that makes the minimum?
5% of that.
5% of that, which 5. Oh god, these numbers are gonna be so nice.
Let's go!
Literally, the 5% is just half a Tesla. Min is 1/2 Tesla.
Wait, is this this is what I
10 and 1/2. I think I can work with those numbers without dying in my soul.
Same. Alright, which that means that the maximum energy of the next loop has to be 1/2 Tesla. Which means that, alright, so basically we want to get it so that we can do a linear into the first loop. So we need to go, I'm going to make the chain. So the chain is going to go a minimum of 1/2 Tesla. Which means this has to
1 over 40 Tesla.
1 over 40 Tesla.
Just multiply the bottom number by 20 each time, right?
Yeah, which means it is 1 over 800 Tesla. What's the Tesla to GeV conversion?
So
I'll get out my computer. By the way, what's my brand new computer?
So what's the energy?
Nice. Hey, you guys want to see my brand new fancy ass computer?
Oh yeah.
Alright, so if we find the GV Tesla conversion, then we can start to...
Why would you buy a gaming laptop?
Actually, hold on. I'm not very smart, okay?
Oh yeah, why would you... Wait, you don't know what...
I think it's a 1050.
Yeah.
1050 it is. I forgot. I'm kind of stressed. I literally got this thing Monday and have been spending all week trying to set it up so it works.
Benji boy.
So before I can do it,
Everyone called me at my old hometown, and I love it better than any nickname I've had here. Don't worry about that. Anyway.
Okay. Alright, let's get the GEV. Wolfram will do it for us, I think.
Yeah, I know.
So how many rooms? I don't know.
Technically, I'm stuck.
Just do Tesla to GEV, and it'll figure it out
This
for
is gonna
us.
take a long while, isn't it? Piss fuck my life.
what's the max?
Yeah.
Wouldn't be more like we can have
More collisions. Because we're using unstable particles, we're gonna have an issue having enough collision.
It's the same particles. Why not just build one big? They're both going the same.
We can't cause them.
So the pro
Why not just make one big?
we should find
And have two sources that go into it, like...
just
Because a source has a set number that controls the ratio of the change. Think about it. Although wait, the double beam magnets are...
The point of a double beam pipe is that they both go in the opposite.
Yes, exactly. If we haven't going in the same direction, we should just make a bigger beam pipe. And if anything, we can have multiple sources.
No, that's not how a double beam pipe works.
Yeah, it is.
Yes, it is.
Yeah,
What do you
mean?
mean?
I mean, a double. The whole point. Yeah. The whole point is they go in opposite directions and then they intersect at some point. That's why. That's how you do it. Proton anti-proton is with a double beam pipe. If you're using the same
proton anti-proton.
anyway,
You're not going to get anything.
we're not saying that. If you do it the same. Well, there are colliders that do that. The LHC does proton anti-proton.
But you're not going to get any data from that.
So, yeah, right? So,
You're not.
anyways, yeah.
So wait, you're doing a double beam.
Yeah, we're actually discussing that now because
I was gonna say
we think a double beam pipe's a bad idea.
because it would go past.
Exactly.
So I was thinking it would be like we could just like
You guys think of that?
no. That's
See,
still
here's what I was thinking. Who says we can't have more than one source feed into the same tube? Just make a bigger beam pipe and have more than one
That's
source.
not how it
That would
works.
work.
Yes, that would work.
No, because they would collide at the same time, or if they would collide before them.
And that's not how it works. In order for the thing to actually accelerate, it has to be pulled by magnets. Different particles require different charges. That I thought was the point of a double beam pipe. You can have two magnets that work with different charges.
See, but they don't have different charges though. They're all muons.
We're 1 GeV to Tesla. Is that right? Or is it Tesla to GeV?
Tesla, we want Tesla to GeV. My issue is I'm not understanding because a double beam pipe. The whole point of a double beam pipe is it goes in different directions.
Apparently they're not compatible.
What do you mean they're not? What's not compatible?
Okay, never mind. Well, in that case, how do we figure out the next?
I'm gonna go 1 second. I'm gonna go ask about double beam pipes.
Yeah,
The point of a double beam pipe is to go
that's what I thought.
directions.
Two particles in the same direction.
They are opposite charges. They're all muons. They have the same charge.
What? Why are you confused? This is only like part of the science. They're having arguments about that. So the problem with that is the different charges. If there are different charges, but what the same both are the same mass, that's what we got to do. The same mass. Because if you're going to do a muon with and the proton or something like that, make sure they have.
We're doing muon.
Okay, why? Sorry, I don't understand your logic here. I'm not going to give you more of that.
What?
Not muon, S muon.
Somewhere in there needs to be a
Oh, shoot.
Look it up. Look it up now. Do it right now. Because I'm right.
Okay.
You're the anti-matter by trying to close.
I don't feel like it.
Oh my god. I'm sorry that you feel like being ignorant, my
I'm sorry you feel like being stuck up.
Wow. Thanks for stating the obvious. I'm so sorry.
Chill.
Hi, I am the avatar of friendliness and brotherly love. I suggest that this conflict stops immediately.
Agape.
Okay, we figured out.
By going as far away from it as possible?
Yeah, that's a good.
Wait. This conversation. Talk back to the desk. It'll cease instead of immediately.
Oh god, stop, my god. Guys, we just need to not interact with other groups because they're weighing us down and stopping our productive thinking.
What productive thinking?
I agree with that.
Are these both going to be muon sources and those are going to be anti-muon sources?
Okay, so
That would be a lot better.
I don't see how we could collide 4 particles at one time, but I can see how we can do 3 because these would have to like split up so that they can actually move. Because otherwise it would just be like
Yeah,
they
that
would
makes
mix each
sense.
other. So they would
That
have to
makes
be like
sense. See, here's the thing I'm worried about. He apparently had the idea that we'd have muon, anti-muon, and muon, anti-muon. The issue with that is we'd end up, it would basically make it so it would be nearly impossible to calculate the energy made from the collision because you'd end up with muon, collisions, muon, anti-muon collisions, and anti-muon, collisions. And we'd have to figure out how often each, which ones were more likely to occur, how likely each one was to occur. It just seems actually literally impossible.
So just do all one particle?
So I was thinking either we could do muon, anti-muon, or we could do all muons or all anti-muons. It doesn't matter. Exactly. We just can't mix them in this, which is why the double beam types use this.
In our case.
Yeah. Exactly. And I don't see why we couldn't have like 2 muon sources feeding into the same tube at the same time with a bigger beam pipe.
It would just.
Because the thing is, there's a set number of muons that can be produced by the muon source. So if we want to have a higher frequency, we just put in another source.
If you're like wrapping up things
Yeah.
together, you're concerned about that.
Wait, literally, this is what I've been arguing this entire time, Benji. Okay, yeah, let's just do that, and then we don't have to use the double beam pipe. Because if we use...
We're going to consider if we're doing muons, the decaying is going to be a factor, so we're going to want to do a lot of RF.
Yeah, we're going to want to put a lot of RF. So that's what I was thinking was we want to supercharge RFs, RF, supercharge that, basically supercharge the shit out of it.
The problem with doing that is, like, the RFs are going to take up space that is going to be magnets, so you're going to need powerful magnets as well.
Yes. So we're going to end up, if we use superconducting RF stations, we're going to need superconducting magnets.
So
What's everybody's job again? I'm drawing.
You're drawing, apparently I'm doing the energy calculations, but I'm shit at math, so if somebody can do that better than me, they can do that. Then there's the write-up and the cost calculations.
And
Benji called the cost calculations. Do you want to do the math or the write-up?
I'll do the math because I saw it.
Okay. I can write. I can write.
You write those words.
I will write those words and I'll write them damn well. All right. Basically, what we have to do is we have to get the drawing done which we have to get the model done, and then the drawing and all the other stuff can be done side by side. So we need to get all this, like the specifications and the model figured out, and then you can work on the drawing. In order for it to actually work, basically I have to go last. Like, you guys have to get the cost and the math done, and then I put it all into things that look nice, and I describe it tomorrow.
Okay, that's great.
I know.
Literally designing a particle accelerator in the day.
Yeah, we're smart, aren't we? Hey, Eden tried to get us started yesterday.
I couldn't find you on Facebook. Also because I don't know your name, but
I procrastinated the hell out of my political theory paper, and so I was not able to attend the meeting yesterday. Also, I was not on campus for most of it because
my dad knows a particle physicist. We can run this by.
Okay, that's helpful.
Let me ask him right now.
Because then, like, we will not totally get wrecked. Because I'm just saying, like, I don't want to do what happened last year. My roommate was in ModPhys last year. I just walked up to him and said, he's laughing. He's like, see, it doesn't even, like, I'm not even the one who's most bothered by this, because I didn't need the extra credit. Like, he was like, you were fucking idiots. He just starts, like, screaming. I'm like, okay. Yeah.
I don't even know.
I don't either. I'm scared. Oh, by the way, okay. So, fun fact. You know how pure Manny is? My roommate? Yeah, well, anyway, we found out something really interesting about him. So, anyway, we decided that since he was so pure, we had to show him porn.
Why?
Just to fix his problems. Anyway, we pull something up, and he's like, you know, he's all like, oh, I don't know about this, but he looks at it for like a split second, and he's like, wait, I recognize that girl. I've met her before. And we were all like, what the hell? No, you haven't. And he's like, yeah, I swear, she was my waitress at a Whataburger in El Paso. And we're like, what the fuck? Like, but we know we can't have him making that up, right? Because how would he have just...
doesn't do anything, he said.
What?
Anyway.
Okay, guys, as a quick warning, most particles against most particles do great. The only exceptions are neutron, electron, or muon. Okay? Electron-positron is good. Muon, anti-muon is good. Muon against anything else, also fine. Proton is fine. It's just that particular pairing. Electron, or positron. Muon.
Okay, let's do pure muons. Okay, well then we'll do. We need to do antimuons in one and muons in the other. So
even other particles.
Exactly. But here, that's the thing. That's why we can't. That's why we don't need a double beam pipe. We only need the double beam pipe if it was a muon, antimuon, muon, antimuon. But that would be bad because we just couldn't. It just
Can you admit I'm right now?
What?
Admit I'm right.
Yes, you're right.
Yes, I know I'm right.
That would be the same
I
thought you were talking about a muon collision. I'm like, why would you do that?
I said antimatter in my argument. I said antimatter annihilation. I said
muons in one.
Let's get this messed up.
All right. Yeah. So what we were saying is the number one, the big one, we want to have an energy of 10 Tesla, which because it's a nice number. And then the minimum energy would be half a Tesla. So to feed into it, this would have to have half a Tesla. To feed into that, this would have to have 1/40th of a Tesla. To feed into that, it'd have to have 1/800th of a Tesla. How low do we want to go before we make our linear? Do you think 1/800th of a Tesla is enough? Low enough?
Oh, I see what you're thinking. You're the math person. You're the calculations with energy.
Actually, yeah.
That's not what I mean.
Yeah. We swapped. I'm doing the write-up. He's doing that.
How do you calculate that? Where do you go?
Yeah, we need to figure out how many RF cavities we want and what we want them to work
Well,
out.
we have 1, 2, 3.
Are we still doing two squared? Are we
See,
still
but here's
doing
no. Here is the thing. Basically, the issue is we're working with muons and anti-muons, which are unstable, which means that the thing you suggested with one RF cavity in each won't work. We need more than one. So basically, what I'm thinking is maybe since we're doing circles, a superconducting RF cavity on each end, you know, and just so like RF. So that way there's two, and we'll make them superconducting so they work better than just a regular RF cavity, even though it'll cost more, it's fine. So we'll just have one of these on each, and we'll have to set them to give a certain amount. And then we should have superconducting in our linear for when we are a linear portion.
Yeah, we got superconducting all over, obviously.
You think this one's for B1 to B10?
Yes.
So you want
The negative ones are really different.
so yeah, so that's what you want now.
They can go through the same circular, they have to go through different linear. But here's the thing, we have to start in a linear, so it won't work. But if we're going to do RF cavities, a superconducting RF cavity is half a meter, they cost 20,000 times E. Can you go down with it? Where E is the accelerating energy in MeV. So the upper limit is 25 MeV. Alright, let's do 25 MeV for each of ours, just to get them really flying, you know?
Yeah, it works to me to like be on the layer that's already
Well, M0 is the original number of particles, T is the particle's lifetime, Y is the usual Lorentz factor, and V is the Lorentz factor. Once an unstable point, a particle is created, you need to calculate how much time it takes before it reaches the collision point, assume it moves at the speed of light, and then use the distance to figure out the time. This will affect your luminosity calculations.
Wait, do we already have a shared Google folder for this?
If not, we need one.
I'm making one
By the
now.
way, you never invited me to the particle physics group. I mean, not the particle physics groups, the ModPhys group.
What ModPhys group?
The ModPhys thing on Drive.
Are you sure?
It says it's not in it.
You didn't give me your email. You gave me a wrong email. You typed it wrong or something.
Alright, so
It's my fault, anyway.
Yeah, it is your fault. It's all your fault.
we're
It's
gonna
my
have
fault.
25 MeV.
How many hours did you sleep again?
Shut up. I don't need sleep because I am perfect and have coffee.
That's not true.
It is true. Replace sleep with coffee. It works.
Surprisingly enough, it doesn't.
It works 5 days in a row, at least.
Why can I not? Is the letter C on your keyboard screwed up?
No.
Just hit it like 5 times and nothing happens. Why can I not type on your keyboard?
Alright, so
Send.
You type in your email.
The polygons always come from the same.
Okay, so we're looking at new ones right now.
How did you name it in Mandarin?
So here's the thing.
oh, it's a Fujitsu keyboard, that's why.
Protons.
Oh.
I was
didn't
like,
realize.
why didn't that
That means
keystroke
like neons can't have
register? And I was like, oh.
I know better. Anyway.
20,000 plus 1,000 times.
So because
I wanted to do something instead of just sitting there.
Whereas B is the actual operating frequency.
So you have this, I mean, think of it as so usually you really have about subtracting down to like or like, but usually either it's like, okay, negligible, or it's like, oh,
Okay, so maybe your address. Alright, I have these only cost
I'm debating whether or not to use this in mine.
I'll use mine, that's not complication, that has an actually good GPU.
Well, Otherwise,
Basically, just use it to there's some way to set it up.
I don't really care about that. That computer has things that than anything else in my life.
Okay, anyways, so you have 10 Tesla rings shoving themselves into the thing. What's our budget?
Okay, we got it. How do we calculate that?
We should decide on how high the energy to be so we can figure out how big our
I think we just decide what energy we want and then calculate everything else.
Okay, what energy do we want to fly at? What G?
All of it.
Okay.
That's impossible.
Considering that we can't use 87% of the
We're struggling. We're trying
Why
to figure
not?
out
You're not trying hard
between, so for like
gotta
the big,
believe in yourself.
the big one,
Can you spell that for dark energy?
That's in this reality.
Oh, you mean 10 Tesla in the magnet?
Yeah. So we're trying to figure out how to get it. So when we're creating a smaller circular accelerators, how do you get between Tesla and like GeV?
Oh, okay. So use that equation. P equals what? QRB, right? Yeah. Okay. P is basically the same as energy if you put it in GeV, right? So you have to do this. So the trick is this is all in SI units, right? So charge, which is always the same number, the standard electron charge. R is the radius. B is the magnetic field.
Okay.
And then that gives you an answer in kilogram meters per second. So get the conversion factor from Wolfram alpha is what I usually do to convert to GeV over C.
Okay.
That's basically the same as energy now.
Yeah.
Okay. Once you have that number, that's the maximum energy, right? Minimum is 5% of that.
Yeah.
So then you put that as like a calculation in Excel and just kind of repeat it, right?
Okay.
So you can get your smaller accelerators.
Okay.
Hang on.
What method do you use to like filter out?
You know how to use Excel?
Like if we're smashing it. Here we go. Like we're having smaller accelerators.
And positive lines. Yeah, they are. Electrons and positive lines almost massless.
Yeah.
Are we supposed to proceed under the effect of their masses?
I hope not, because that would suck.
40 billion alien. We don't have to do any calculation. Why are you the one complaining?
Alright, can we not be rude to each other? Let's just do it.
What if we
Not being rude.
for a cow I can estimate probably about 1.5?
Oh, that's probably rude. Oops.
We make that the ratio for you.
Look at those numbers. Wowie.
Alright, so
Okay, anyway.
alright. So yeah. We need to figure out in order to have
So what's, we need to know the radius. How big do we want these things?
well that is going to be calculated based on the maximum energy. So can you go down to the equations?
So maybe allow like
VRQ.
Yeah. So B is oh god, I'm an idiot.
What?
GeV is energy. Tesla is magnetic field.
Yes.
So we don't need to convert those. Tesla's not even what we're supposed to be changing. Like the max and min is not even relevant.
We're supposed to find the energy, which is almost equal to the P
Momentum.
muons and anti-muons. So it's
Yeah.
almost equal for electrons and positons, and it is even further away for protons and electrons. They're obscenely close.
Yeah, so basically E equals P as far as we're concerned. So basically we need to figure out based on
What energy?
charge of a muon times the radius times the Okay, we can just set a radius and then use it to find the energy.
Yeah. We basically all we have to do is set energy and radius, and that's basically it.
Well, no, we need to set radius. That's it, because we already have the charge of the particle, and we already have the Tesla for this. So basically, we just need to go ahead and find the
Radius.
We just need to. But that's arbitrary. We can just set it.
I know. What do we need? What do we want the radius to be?
It needs to be in meters. So let's make it
7 billion.
No.
The radius will also be how many
100.
yes. The charge of the magnet. So literally, we just need to set a radius and then we can do it.
How about
100 meters is bad. Bad.
Way too much or
Way too little. The Tevatron is 1,000 meters across, and we want to be bigger than the
We
Tevatron.
have $40 billion.
Exactly. I got that. All right, let's just make it 20,000 meters across. Yeah, 20,000 meters across
For each circle or all together?
for each circle. 20,000 meters across for these.
for each small circle?
For each big circle, 20,000 meters across.
Okay, those numbers I can work with.
And then just go into Wolfram Alpha, do the conversion from the P for that equation, P equals QRV, is going to end up being in, it's going to end up, no, it's going to be in SI units. So you need to convert from kilogram meters a second to GeV, which Wolfram will do for you. It's working.
Is it kilograms per second, kilograms per second squared?
Kilogram meters per second.
If I were at my old high school, I'd probably be sleeping right now.
Sleeping?
Yeah.
Okay, more.
1 kilogram. They're not
Kilograms per meter squared per second squared.
Yeah.
second square.
Okay. Why are you? Oh, I know why. Because you're stupid and don't understand that. This is how it. Okay, let's see if this works now. It's apparently distant. I didn't realize that that's a distance.
Well, wait, momentum is. Yeah. Hold on. Okay. Kilogram meter squared per second squared is not momentum, is it? That was just kilogram meters per second.
Actually, that's the bad
Because it's just mass times velocity, so it'll be kilograms times meters per second.
Momentum.
Seeing as this is gonna
Wait a minute. This
it's just
momentum is
kilograms.
DeV over C. Energy is C. So we have to multiply by a factor of C.
No, that doesn't matter. Okay.
But C is
No, listen. We're doing. We're going to be working in SI units, which means we can basically use the units of P equals MV, which means that it's just we're going to get an answer in kilograms times meters per second, not meters squared per second squared. It's kilograms kilogram meters per second. We convert it to GeV using this. So literally, no, it's not. Just eliminate the squareds, and you've got what you're supposed to do for your conversion. It's kilogram meters per second.
So do this.
Do this without the squareds. You put in squareds. We don't need those. Those are wrong. So just go up. Just eliminate the squares. Just kilogram meters per second.
20% of our grade is based on creativity.
That's the.
Let's get creative.
That's what we want.
Are not compatible.
No. Okay, that's not how. Momentum's in kilogram meters per second, not kilogram meters squared.
All we have to do is insert the numbers in for the squares. Basically, we don't square the values. That's it. Is what I'm trying to say.
We need to create a radius.
If you're in charge of math, if that's what you think you're supposed to do it.
Charge of math.
Well, okay, whatever. Whoever's in charge, just do it. Just do it. Fine, okay.
Basically, just insert the N and X. Yeah, D. You have to have squares in here, but you don't need them. So I'm trying to say they're not important.
Oh God. Okay, yeah, it's squared. Never mind. Okay, I see. Because energy is kilogram meters squared per second squared. Yeah, okay, fine. Yeah. Put in the squares. You're both right. It's just you're more
right?
It's true that momentum is not in kilogram meters squared per second squared. However, it's also true that even though we're using momentum, we're not using momentum.
Yeah.
That's where I got tripped up. So yeah, we just want to convert from
So
that.
that's a factor of dB.
So yeah, so seriously, just convert. Just type in convert.
Why?
Because then it'll open up a converter, and you can just type in.
No, why does this number look familiar?
Why did number?
That's what 10 for 2 times 10 to the 9. It's like, it's almost
Our attack is accelerated 10 times.
Alright, so just type in convert before that, and it'll do everything for you. It'll give you a little option where it'll do everything for you. Or at least it's supposed to. Here. I got it. It's easier if you do it as so. So go to, here, just go to actualwolframalpha.com. Don't even search anything. Just go.
27.
There you go.
Okay, so.
Alright, now scroll down. Units and measures. Click units. Click conversions. And now you can look down. Okay, here. I'll show you. It's easier if I do it.
here's MEV. So,
But that's not what we're doing.
here's MEV.
Yeah, okay. Sure, do MEV.
54.
Yeah.
Okay, just input this in here. We're doing this all nicely, right? We can change this to joules. Okay.
What is the proper term for momentum? It's kilograms per meters per second.
Now
What is that?
33.
What is that? What do you mean you from meters? What do you mean you from meters?
Okay, give me one second. 500. Wow, that was nice.
Which is better because reduce your magnets.
I don't know. Oh, we have to go.
Oh, it should be G. Yes, see it? Kilogram meters per second to GeV.
Can be one and the same.